Did you know that one of the most infamous places on Earth might not be mysterious because it's empty, but because it's alive? Today, we need to talk about a discovery that sounds like it escaped a late-night conspiracy forum, but didn't. A place where ships vanish, compasses lose their minds, and pilots swear the ocean itself starts behaving wrong. Not haunted, not cursed, just misunderstood in the most unsettling way possible. The Bermuda Triangle has spent decades being blamed on aliens, time warps, and angry sea gods with bad tempers. But scientists recently looked closer, much closer, and what they found was quieter than fiction and somehow far more disturbing. If you enjoy strange science, real investigations, and nature behaving like it absolutely does not care about your comfort, consider liking the video, subscribing, and leaving a comment, but only if you actually enjoy this kind of thing. No pressure, the ocean already applies enough of that. Now grab some popcorn, or a blanket, or both, because we're about to talk about underwater explosions that leave no fire, animals that rewrite navigation rules, and geological forces that make ships disappear without breaking a single wave. Ask yourself this: what if the triangle doesn't trap ships? What if it simply lets them fall through? What if the ocean floor there is still moving, breathing, releasing things it shouldn't? And what would you do if you were the researcher staring at data that says, very calmly, something down there can erase a vessel in seconds? Because that's exactly where you are now, standing on the deck, instruments humming, water calm, and the ocean beneath you doing something it absolutely shouldn't. At first glance, the Bermuda Triangle looks painfully ordinary. Blue water, gentle waves, sunlight bouncing off the surface like a postcard. And that's exactly what made early investigators dismiss it. Nothing here looks dangerous. But scientists now know this region can switch from peaceful to lethal without warning, not with storms, but with physics. The kind you don't hear coming. Let's slow this down. You're standing on the deck of a ship. The air smells like salt and warm metal. The engine hums steadily. No wind, no clouds. This is the kind of ocean day sailors dream about. And that's the trap, because in this part of the Atlantic, danger doesn't announce itself with thunder. It waits for math to line up. Researchers studying the region noticed something unsettling. Ships didn't report bad weather before disappearing. No distress calls about waves. No panic about wind. Just silence. That forced scientists to stop looking at the surface and start looking through it. What they found is that the water here can change its physical behavior faster than a human can react. Subsurface pressure shifts, gas pockets destabilize, ocean density changes in localized zones. Imagine standing on solid ground that suddenly decides it would rather be air. You don't fall dramatically, you just aren't supported anymore. And the wild part? From above, nothing changes. The sea doesn't froth, no whirlpools, no cinematic chaos. A ship can be floating normally 1 second and losing buoyancy the next, while the horizon remains perfectly calm. It's like pulling a chair out from under someone, except the chair is the ocean and it never apologizes. For decades, people blamed monsters, magnets, or madness. Turns out the real threat is worse. It's an environment that looks safe, feels safe, and follows rules, just not the ones you expect. And by the time you realize that, the water has already made its decision. Let's talk about what they found beneath the surface. The ocean floor here isn't stable rock. It's layered with methane hydrates, frozen gas trapped under pressure. When that pressure shifts, the gas erupts upward, not violently, quietly. And when it does, water loses density. Ships don't sink, they simply drop, like stepping onto air that pretends to be solid. To understand how unsettling this is, picture methane hydrates as icy cages holding gas molecules hostage. They form in cold, high-pressure environments exactly like the deep sea floor beneath the Bermuda Triangle. For years, scientists thought these deposits were mostly stable. Turns out they're more like a soda bottle that's been shaken and left in the sun. A small temperature increase, a seismic tremor you wouldn't even feel on land. A shift in ocean currents. That's all it takes. The hydrates destabilize, releasing massive plumes of methane gas that rise through the water column. No explosion, no warning, just bubbles. Millions of them. Here's where physics becomes rude. Water filled with gas bubbles becomes less dense. And buoyancy, the one thing ships rely on, depends entirely on density. If the water beneath a vessel suddenly behaves more like foam than liquid, the ship doesn't get dragged down. It loses support. Gravity does the rest. Experiments have shown this can happen in seconds. One moment you're floating, the next, the ocean forgets how to hold you. From above, there's no dramatic evidence, no wreckage floating around like a movie scene. The ship slips under, intact, and the surface reseals itself like nothing happened. Early theories dismissed this as impossible, too rare, too neat. But deep-sea surveys keep finding hydrate fields exactly where disappearances cluster. The seafloor isn't dead, it's active, breathing, and occasionally exhaling just enough to make gravity win. You can't fight it, you can't steer away from it, and you won't hear it coming, which is a deeply unfair way for an ocean to behave, but oceans have never been known for fairness. For decades, people asked why wreckage was missing. No debris, no oil slicks, no survivors. The answer may be brutally simple. If a vessel suddenly loses buoyancy, it doesn't break apart on the surface, it plunges straight down. The ocean closes above it, and the sea erases its own fingerprints. Let's walk through what that actually means, because it's quieter than most disasters and far more effective. When ships sink during storms, they usually tear apart. Wood splinters, metal twists, cargo floats. Evidence spreads across the surface like a confession. But in regions like the Bermuda Triangle, the failure happens underneath, not above. A rapid loss of buoyancy turns a ship into a falling object. It doesn't roll, it doesn't tip dramatically, it drops. And as it descends, pressure increases fast. Hulls that were never designed for depth begin to compress inward. By the time structural failure occurs, it's already far below the reach of sunlight, and far from where anyone would think to look. Oil doesn't rise neatly either. At depth, it disperses. Cold water thickens it. Currents shred it into microscopic traces that vanish into the ocean's background noise. From the surface, nothing looks wrong. Just open water doing what open water does. This is why search crews often found nothing. No trail to follow, no wreckage field to map. The ocean doesn't scatter clues when gravity does the work cleanly. It hides them. For years, this absence fueled supernatural explanations. Something must have taken the ships. Something must have removed the evidence. But the truth is less dramatic and more unsettling. Nothing took them. Physics did. And physics doesn't leave souvenirs. It's not mysterious because it's complex. It's mysterious because it's efficient, and that's a far more uncomfortable realization. Now lift your eyes upward, because the triangle doesn't stop at the waterline. Scientists have documented strange atmospheric anomalies here, sudden downdrafts, microbursts, and fast-forming clouds that confuse instruments and pilots alike. Imagine flying through air that suddenly behaves like water. Your altimeter lies, your compass drifts, and you don't realize it until gravity reminds you. This region of the Bermuda Triangle sits where warm tropical air collides with cooler northern systems. That clash creates unstable pockets of atmosphere that can collapse without warning. No long buildup, no dramatic storm front, just air that suddenly decides it wants to go down fast. Pilots who've flown through these conditions describe something deeply unsettling. The plane feels fine, engines normal, controls responsive. And then the aircraft begins to sink, not because it's failing, but because the air beneath it is. Microbursts can force planes downward at speeds faster than they can climb, even at full power. It's like trying to swim upward in a waterfall. Add to that rapidly forming cloud walls that erase the horizon in seconds. Visual references vanish. Your inner ear disagrees with your eyes. The brain, desperate for stability, starts making corrections that only make things worse. By the time you realize what's happening, you're already responding to bad information. Older aircraft were especially vulnerable. Early navigation relied heavily on pressure readings and magnetic headings, exactly the things this region distorts. Pilots weren't reckless. They were betrayed by instruments behaving perfectly in the wrong environment. And here's the cruelest part. From the ground, the sky can look calm. No thunder, no lightning, just clouds minding their business. Which means when something goes wrong up there, no one sees it happen. The ocean hides its dangers below. The sky hides them in plain sight. And together, they make a very convincing case that the Bermuda Triangle doesn't need myths to be dangerous. It already has physics doing the work. This is where things get unsettlingly precise. The Bermuda Triangle sits near one of the few places on Earth where true north and magnetic north briefly align and then don't. Small shifts in Earth's magnetic field can cause navigational errors just large enough to be fatal. Not dramatic, just enough to put you slightly somewhere else. Here's the problem. Navigation assumes consistency. Your compass points north, your charts agree, your corrections make sense. But in this region, Earth's magnetic field behaves like it's having an off day. Tiny fluctuations can cause compasses to drift without warning, not spin wildly, just lie politely. A few degrees off course doesn't sound dangerous, until you're flying hundreds of kilometers over open water, or sailing at night, or relying on dead reckoning. That small error compounds. Minutes turn into miles. Miles turn into fuel problems. And suddenly, you're not where you think you are, which is one of the most dangerous situations a pilot or captain can be in. Early crews didn't know this. They trusted their instruments because instruments are supposed to be objective. When something went wrong, it felt supernatural. The compass said one thing, reality said another, and reality always wins. Modern navigation systems compensate for this now. Satellites don't care about magnetic tantrums. But before that, humans were navigating a planet that quietly moved the goalposts. The unsettling truth is that nothing here forces you off course violently. It nudges you, gently, repeatedly, until you realize too late that north was never quite where you thought it was. Here's where biology enters the chat. Deep-sea animals in this region behave differently. Species usually separated by depth appear together. Creatures adapted to pressure extremes migrate upward temporarily, as if something below tells them to move. Nature doesn't panic, but it does relocate when the ground starts misbehaving. Marine biologists studying the Bermuda Triangle started noticing patterns that didn't fit textbooks. Deep water fish appearing far above their normal range. Squid species showing up where light shouldn't reach. Creatures built for crushing pressure suddenly wandering into shallower zones like they took a wrong elevator. This isn't random. Animals don't migrate for fun. Many deep-sea species are exquisitely sensitive to pressure changes, chemical shifts, and vibrations. When methane releases, seismic micro-movements, or temperature anomalies ripple through the seafloor, these animals feel it long before instruments do. To them, it's an eviction notice. Think of it like smoke in a building. You don't wait to see flames, you move. Deep-sea creatures do the same, except their exits lead upward, sideways, and occasionally into places humans don't expect them to be. What's unsettling is how consistent this behavior is. These migrations often align with geological instability. Not storms, not seasonal changes. The ocean floor itself signals something is off, and the food chain responds accordingly. To sailors and pilots in the past, these sightings fueled legends. Strange animals appearing near the surface, creatures thought mythical, suddenly very real, but nothing supernatural was happening. It was ecology reacting to geology. The ocean communicates constantly. Pressure, sound, chemistry. Humans mostly ignore it. Animals can't afford to. So when the seafloor breathes, shifts, or releases gas, life listens and moves out of the way. Which is ironic, because the creatures that seem terrifying to us are often just trying to escape something far worse happening beneath them. Those who lived describe time distortion, confusion, sudden silence, not fear, disorientation. Scientists believe rapid pressure and electromagnetic shifts can affect the human inner ear and brain, warping perception. You don't feel attacked, you feel wrong. Which is far more dangerous when you're responsible for a ship or a plane. Survivor reports from incidents in the Bermuda Triangle are unsettlingly consistent. Engines didn't explode, controls didn't fail outright. Instead, everything felt slightly off. Sounds dulled, time stretched. Movements felt delayed, like the world was running a fraction of a second behind schedule. This matters because the human brain relies heavily on the inner ear to understand balance, motion, and orientation. When pressure changes rapidly or electromagnetic fields fluctuate, that system can misfire. Your eyes say one thing, your body says another, and your brain tries to reconcile the disagreement by guessing. That guess is often wrong. Pilots describe moments where altitude felt stable while instruments quietly disagreed. Sailors recall calm seas paired with an inexplicable sense of falling. In extreme cases, spatial disorientation can make left feel like right, up feel like down, and seconds feel much longer than they are. You don't panic, you compensate, which is exactly the problem. This phenomenon is well documented in aviation psychology. Even trained professionals can lose situational awareness in environments that scramble sensory input. The Bermuda Triangle just happens to combine several of those triggers at once: pressure anomalies, magnetic variation, and atmospheric instability. To an outsider, it sounds psychological. To the person experiencing it, it feels physical, real, immediate, and deeply convincing. That's why survivors struggle to explain it. There's no monster to point to, no single moment of terror, just the overwhelming certainty that reality briefly stopped agreeing with itself. And when your senses betray you in the middle of open ocean or empty sky, confusion isn't just uncomfortable, it's dangerous. Aliens didn't cause this, neither did Atlantis. But the myths weren't born from nothing. They were early humans, trying to explain an environment that breaks normal rules. When science finally caught up, it didn't erase the mystery, it just gave it better lighting, and somehow made it worse. For centuries, sailors crossing the Bermuda Triangle noticed patterns they couldn't explain. Ships vanished on calm days. Compasses disagreed. Time felt strange. Without data, the human brain does what it always does. It tells stories. Gods, curses, portals, anything that makes chaos feel intentional. What science revealed is less theatrical, but far more unsettling. There is no single cause, no switch you can point to, just a rare overlap of geological instability, atmospheric chaos, magnetic quirks, and ocean physics all stacked in one place like a bad coincidence that never moved out. The myths failed in their explanations, not their instincts. Something really was off here. People just didn't have the language for methane hydrates, microbursts, or electromagnetic variation, so they reached for what they had. Even today, knowing the mechanisms doesn't make them comforting. If anything, it removes the illusion of control. You can't negotiate with pressure, you can't outsmart buoyancy loss. You can't argue with a compass that's technically correct but contextually useless. So no, the triangle isn't supernatural. But it is a reminder that nature doesn't need monsters to be dangerous. It only needs systems that don't care whether you understand them or not. And maybe that's why the myths refuse to die. Because deep down, we recognize the truth hiding underneath them. The world is stranger than we're comfortable admitting, even when we can explain it. And that brings us back to the surface. If this video made you curious, uncomfortable, or just a little more respectful of the ocean, consider liking the video and subscribing for more stories like this. And if you ever find yourself sailing through perfectly calm water that suddenly feels wrong, maybe trust that feeling. Thank you guys for watching. It really means a lot. I'll see you in the next one.